Now, what you're looking at is Earth. The distance is 25,513 km. The radius is 6,078.1 km, and the phase angle is 0.8 degrees. Now, let's using this software, which is Celestial, let's take a look at Jupiter. Now, the Celestial um, camera is targeting towards Jupiter, and now let's take a look at Jupiter. Sorry, I have to do a bit of adjustments. Okay, now this is Jupiter. The distance is 757,360 km. Radius is 7,492 km. The phase angle is 119.7 degrees. Okay, if you compare this to Earth, the radius, the distance, and the phase angle are really massive. And Jupiter is a gas giant. Its phase angle and its radius is very big. Now let's take a look at some of Jupiter's moon. The moon I'm pointing to is the Io of Jupiter, which is the first moon of Jupiter. The distance is 7,457,900 km. The radius is 1,821.6 km. The phase angle is 113.6 degrees. Now, let's take a look at the second moon of Jupiter, which is Europa. The distance is 6,669,600 km. The radius is 1,560.8 km. The phase angle is 115.7 degrees. Now, for the third moon of Jupiter, Ganymede, which we will be using for this project, is 8,222 and 100 km. The radius is 2,631.2 km. The phase angle is 122.4 degrees. Ganymede is the biggest moon of Jupiter. Therefore, we will be targeting towards Ganymede, as it is easily seen and it is easy to observe in the night sky. Now, let's take a closer look, and we can also see another moon, which is the Amalthea of Jupiter. Jupiter's fourth moon. The distance is 6,050 and 700 km. The radius is 134 km. The phase angle is 114.3 degrees. Compared to other moon, this moon is really very small. Jupiter. Jupiter is the fifth planet from the Sun and the largest planet within the solar system. It is a gas giant with mass 1,000th of the Sun, but is 2.5 times the mass of all other planets in our solar system combined. Jupiter is classified as a gas giant along with Saturn, Uranus, and Neptune. Together, these four planets are sometimes referred to as the Jovian or outer planets. The planet was known by astronomers of ancient times and was associated with the mythology of religious beliefs of many cultures. The Romans named the planet after the Roman god Jupiter. When viewed from Earth, Jupiter can reach an apparent magnitude of -2.94, making it on average the third brightest object in the night sky after the Moon and Venus. Mars can be briefly measured Jupiter's brightness at certain points in its orbit. Jupiter is primarily composed of hydrogen, with a quarter of its mass being helium. Although helium only comprises about a tenth of the number of molecules, it may also have a rocky core of heavier elements. Because of this rapid rotation, Jupiter's shape is that of an oblate spheroid. It possesses a slight but noticeable bulge around the equator. The outer atmosphere is visibly prominent, result in the Great Red Spot, a giant storm that is known to have existed since at least the 17th century, when it was first seen by telescope. Surrounding the planet is a faint planetary ring system and a powerful magnetosphere. There are also at least 67 moons, including 4 large moons called the Galilean moons, that were first discovered by Galileo Galilei in 1610. Ganymede, the largest of these moons, has a diameter greater than that of the planet of Mercury. Jupiter has been explored on several occasions by robotic spacecraft, most notably during the earlier Pioneer and Voyager flyby missions, and later by the Galileo orbiter. The most recent probe to visit Jupiter was the Pluto-bound New Horizons spacecraft in late February 2007. The, the probe used the gravity from Jupiter to increase its speed. Future targets for exploration in the Jovian system include the possible ice-covered liquid ocean on the moon, Europa. Have you ever found the mass of Jupiter using the distance between it and the moons?
Huh?
Well, that's what my group is going to do. We're going to find the mass of Jupiter using one of its moon's orbit, and this can be found using Kepler's third law and Newton's second law. The methodology is we need Kepler's third law and Newton's second law as there's no mass in Kepler's third law. And Kepler's third law is p squared equals to a cubed. Okay, in which a is equal to semi-major axis of an elliptical or circular orbit, and p is equals to time for one complete orbit around the sun. In this formula, when we are working it out, the units needs to be consistent. Example, units used for the semi-major axis as astronomical units, then answer must be in years. For this, we will also need the help of a scientific calculator as the results must be very accurate. Now Kiran will talk about the Sir Isaac Newton's law of universal gravitation.
Well, the Sir Isaac Newton's law of universal gravitation is force is equal to force is F force which is F is equal to Gm slash slash R square, where and G is the universal gravitational constant and M is the mass of Jupiter, and M is the smaller, the not the caps lock one, the small M is the mass of the moon we chose, and R is equal to the distance of the center of the moon. You choose from the distance to the Saturn center, so that we can figure out the mass using its orbitational movements. And now Subramani will say what moon are we going to choose.
Okay, we have chosen Ganymede as it's one of the moons that we can use for our calculations. Two more of Jupiter's moon can be chosen to confirm our calculations, but Ganymede is the biggest moon of Jupiter, therefore it will be more visible during the night. Therefore, even if you get slightly different answers for Jupiter's mass, as long as the answers have the same order to magnitude power of 10 inches, your answers are probably correct. Therefore, to ensure that our answers are correct, um, our answers are reliable, we will try and do
Another moon.
more than one moon. Firstly, take a telescope and focus it at a stationary point, such as the JTC building, which is near the Science Center. Then from there, we'll manually turn the telescope to where Jupiter is. And later, we will focus the telescope such that Ganymede is also included in the view of the telescope. Then we'll start taking pictures of Ganymede and Jupiter.
At like intervals of 10 minutes, so that we can know its orbitational movement and we can do our calculations. Unfortunately, this time, in this period of time, we can't do Jupiter, as Jupiter is not in, as we can't see Jupiter in this time of in the period of time.
Therefore, Jupiter only appears from November to December. So we will also consider trying to start this project during that period of time, and we will also like to get other preparations ready before it, so that we will be ready to take pictures. Yeah.
Well, now we're going to tell about the risk in it. When using the telescope, we will have adult supervision, so we will not see anything like the moon, which is too bright, and it will not hurt our eyes. And we will use a steady telescope, unlike not a fragile one, so it will not fall and like will destroy the whole
We,
project.
we will also consider using filters, as filters may prevent our eyes from being hurt, as it actually filters the amount of light that enters the telescope. And we may also we'll also ask an adult to set the magnification and the angle properly, so we will not see anything too bright or harmful to us. We may also consider handling the telescopes with care, as some of them are fragile and the adults may not want their telescopes to be spoiled. Therefore, we will use the telescope under their supervision. Some measures we may consider.
As science center, as we're doing this project in the science center, is science center observatory, which is a free public place. There will be visitors who may be there to observe the stars, and they will use the telescopes that we might be using too. Therefore, we might get deprived of taking pictures using both the telescopes and the time. We might want to wait till all the people have seen through the telescope, and then we will use the telescope and take pictures. Then we might also take note of using the telescope ourselves, as we are depriving other visitors from using the telescope. As we are using the Jupiter's Gamete moon because it's all day, it's all time in the, it's always in the night, and we can see it all in the night. And so our proposed, so we're going to tell how why we choose this topic, because we are, because basically we have an interest in space science, and as we are also volunteers in the science center observatory. It's more easier for us to go to use the telescope than other visitors.
And let me talk about the telescopes we may be using. The smaller telescope that you're seeing is the Celestron Nexstar SLT range, and the bigger telescope you're seeing now is the Celestar Nexstar 6C6. Now, for a while, take a look at the pictures we have taken about the telescopes. Okay, now we may like to talk about the feasibility of the research. The research is feasible as it is possible for us to study celestial objects using professional telescopes and professional cameras. And it is also feasible as we are all volunteers in Science Center. So we can use the telescopes ourselves without even without without even asking them. And the manageability of the research, Kiran will talk about it.
It's manageable for us because Jupiter is exactly coming that period. It's like very easy for us to see because we have powerful telescopes, and the moon, furthermore the moon, the moon is also going to be there with the Jupiter, and so it really very manageable for us. So thank you
For listening to us, and
and we
we
will
hope
further
that.
update you about our investigation soon.
Okay, thank you.